Alright, for the rest of this back page, we are adding and subtracting square roots, and the only way you can combine them by adding and subtracting is if the parts under the square roots are exact matches. So this one has a 2 under the square root, and so does this. These are matches. If I have 10 of these square roots of 2, and I take 7 of the square roots of 2 away, then my square root of 2, I only have 3 left. So don't do anything to the number under the square root sign. It doesn't change. But as long as these are the same, exactly the same, then the outside numbers can do whatever operation is indicated here. 10 minus 7 is 3. Of course, they're not all going to be that easy. This one was already broken down and ready to work. You can see when you look at number 19 that 150x is not the same thing as 54x. So on this one, you have to break both of these down, and once those are broken down, maybe there will be a match that you can combine like terms. So you're looking for perfect square factors of 150, and let me just remind you that if you want to find factor pairs, like sometimes when you have a number as large as 150, it's hard for you to find the factor pairs. If you type in under y equals the number 150 divided by x, and you go to the table, so I'm pressing second graph, my table says 1 times 150, 2 times 75, 3 times 50, I'm skipping the decimal, 5 times 30, 6 times 25. So lots of different options. I know that this is kind of small, but glance through here and see if you can pick out which factor pair you would use to break down your 150. I hope that you have chosen the 6 and the 25, because 25 is the perfect square. 50 is not, 75 is not, 150 is not. So I'm going to break it down to 6 times 25. So my 150 is 6 times 25, and you still have that x. Now that x, they can only move out in pairs, and I only have 1. So this x is just going to be a stray x that stays inside. What's going to move out is this 25. Okay, I still need to do the same thing with the 54. So I need to decide what to break the 54 down into. You may already know, but in case you don't, if you just type in 54 divided by x under the y equals, and you go to your table, and you can see it's 1 times 54, 2 times 27, 3 times 18, and 6 times 9. And can you pick out the pair that has a perfect square factor in it? And I hope that you have selected 6 times 9, since 9 is a perfect square. So your 54 is going to break down to 6 times 9, where the 9 moves out. And this one also just has a spare x. Alright, so move this 25 out. The square root of 25 is 5. What's left on the inside is 6x. Plus, the square root of 9 is 3. On the inside, I have a 6x left. And now you can see square root of 6x, square root of 6x. So those are the same, which means I can combine them. 5 plus 3 makes 8 square roots of 6x. Okay. Number 20, you're again doing the same thing. The only difference here is there are also numbers on the outside, but you guys know that if you move a perfect square out and there's already a number on the outside, it just multiplies. So 12 and 27 don't match, so I need to see if I can break them down. I have my 5x out here. 12 breaks down to 6 times 2 and 3 times 4. You know to use the 3 times 4 because 4 is the perfect square. This one has the 3x on the outside. 27 is 9 times 3, where the 9 will move out. So moving both of these out, I have 5x. The 4 moves out and turns into a 2. The 3 stays in. Over here I have 3x. The 9 moves out and turns into a 3. This 3 stays inside. So you can see that they're going to match square root of 3, square root of 3. This actually makes 10x on the square root of 3. This makes 9x on the square root of 3 because I'm multiplying in those cases. 10x square root of 3 plus 9x square root of 3 is 19x on the square root of 3. All right, almost done. This one is so easy that you'll accidentally make it hard. A lot of people think it makes a square root of 14. Please don't do that. You don't ever add the numbers under a square root sign like that. If they would write the understood ones in, I don't think you would miss this one, but they will probably never write those understood ones in. If you have one square root of 7 and you get one more square root of 7, I hope it makes sense that you have two square roots of 7. 7 is a prime number. It doesn't break down. That's the answer, and I'm done. This one, of course, can be that easy, but it's your last problem. So this one is just like number 20 that we just did. We're going to break stuff down. When we move it out, there's already stuff outside. We'll multiply it. So I have my 10. My 20, I would use 5 and 4, since 4 is the only perfect square that divides evenly into 20. My x's are odd, so I'll go ahead and bump one away. So I have 4 x's, and here's my last one to make my total of 5 x's. So you can see these two things will move out, the 4 and the x to the 4th, and they'll join this 10. So my 10 is going to be multiplied by the square root of 4 and the square root of x to the 4. And on the inside, I'll have 5 and x left over. So I'm just going to go ahead and finish this part all the way down. This makes 20x squared on the square root of 5x. Now I still have this other part I haven't dealt with yet. When I move it out, the square root of 9 is 3. The square root of x squared is x to the 1st. On the inside, my 5 and my x. And my last step here is to multiply these. So the 4 and the 3 are 12. X to the 1st times x to the 1st. Remember, when you multiply x's, these exponents add. So this makes x squared on the square root of 5x. And now I'm checking to see if these are like terms. And they are. They both have a 5x under the square root sign. So if I have 20x squared and I'm taking away 12x squareds, really I have 8x squareds on the square root of 5x.